Hello everyone, this is Rahul Shrestha and I am here to present the third part of measurement chapter for class 8. If you remember, in our last class, I asked you people to find all the quantities on which force and pressure depends on. So let's look at force first. We know that force is the product of mass and acceleration, where this mass is a fundamental quantity and acceleration is a derived quantity, which is the change in velocity per unit time. Now again, velocity being distance upon time, we can apply all of these values and rewrite the formula of force like this, which shows us all the dependent quantities of force. So now we can say that force, being a derived quantity, is dependent on mass, length and time. In the same manner, we know that pressure is force applied per unit area. Now we can replace the value of this force with the value we derived just now and can have a simplified value of pressure as this. Now here, area can be written as the product of two lengths, which again shows pressure to be a derived quantity which is dependent on mass, length and time. So in this manner, by using the definitions and formulas of the quantities, we can derive the related dependent fundamental quantities of all other derived quantities. Now moving forward with our chapter, today the topic of our discussion is units. So what exactly are units? Unit is a quantity of a constant magnitude which is used to measure the magnitude of other unknown quantity of the same kind. Now we'll get back to this definition again, but before this, try to understand that units and measurement always go hands in hands. Units are an integral part of measurement, and measurement has always been an integral part of our day-to-day life. Whether knowingly or unknowingly, we measure different things every single day. Things like checking time, counting money, cooking, buying or selling, having a new suit, and a lot of other activities. Each involve measurement in some form or the other. In this modern world, we have thousands of different tools to measure different quantities. Every day, we use countless numbers of tools and techniques to quantify different things as per our need. But it was not like this since the very beginning. People never had these tools in the ancient times. So those ancient people resorted to using some traditional ways of measuring stuffs. Traditionally, in those days, if the people had to measure something, say length, they used to use their hand span, cubit, their foot span, pace, and sticks for measuring. So back in those days, suppose if the people had to measure the length of this table, they would use their hand span for doing it. But using one's hand span was not enough to cover the length of the whole table. So they would use their hand span multiple times in order to get the proper length, which in this case is 5 hand span. So here this hand span works as the standard unit that they use to measure the length, and 5 times of this hand span came out to be the total length of the table. And this is how hand span, being a traditional unit for measuring length, worked. But using these traditional means of measurement often created a lot of confusion and misunderstanding among them. As different people had different sizes of body parts and had different sizes of sticks they used for measurement, so in order to combat this confusion, people created some predefined standard sizes of quantities in order to measure different things. And this is how units were developed. The word unit is itself derived from a Latin word unus, which means one. So basically, unit means one quantity of anything. So in order to measure length, people took a set amount of length and called it meter. And this is how meter was developed as a standard unit for measuring length. So if I say meter, I am talking about this much amount of length. And if I say 3 meters, I am talking about this meter times 3 amount of total length. So this meter here is a standard amount of length that we have established, and 3 meters is nothing but this same single unit, that is meter, taken thrice. In the same manner, in order to measure mass, a standard unit kilogram was developed. To measure volume, liter, and to measure all the different physical quantities, different types of other units were developed. Now coming back to our definition, unit is a quantity of a constant magnitude. Remember, the size or magnitude of the units are always constant. They are set as a standard which does not change. That means कि 1 meter here in Nepal is same as 1 meter in the United States or anywhere around this world. 1 meter right now is same as 1 meter 100 years ago, and it will be same after hundreds of years in the future as well. So units is a quantity of a constant magnitude or size which is used to measure the magnitude of other unknown quantities of the same kind. All the different fundamental and derived quantities have their own set of units that we can use in order to measure them. I'm just showing you the related units of some of the physical quantities right now. Feel free to pause the video if you wish to check them out. Now there are certain rules of using the units while measuring the quantities. The first rule tells us that the symbol of a unit which is named after a scientist should start with a capital letter. For example, Newton, which is the unit of force, should be written as capital N. Kelvin, the unit of temperature, should be written as capital K. In that same manner, the symbols of units like ampere, candela, joule, etc. should all be written in capital letters. The second rule tells us that the symbol of a unit which is not named after a scientist should start with a small letter. Like meter, which is not named after a scientist, should be written as small m. Seconds, kilograms, each one of these particular units are not named after any scientist, so each one of these units must be written in small letters. Now the third rule tells us while writing the full form of the units, we must always write it in small letters. The next rule tells us that the compound unit which are obtained from the units of two or more physical quantities should be written either by putting a dot or leaving a space between symbols of two units. You can see the example of the unit of torque, which is Newton meter, should be written with a space or a dot in between the two units, which is Newton and meter. The next rule tells us that the denominator in a compound unit should be written with negative powers. You can see that the unit of density, which is kilogram per meter cube, should be written with a negative power. And the last rule tells us that symbols of units should never be written in plural form. Like if you want to write 5 kilograms, it should be written as 5 kg and not 5 kgs. Okay, so these are certain rules about units that you should remember and use whenever you are expressing any physical quantity. I'm done with today's class. I hope you might have understood everything I taught about units today. We'll meet again next time. Till then, take care and be safe. Thank you.